Good morning, grade 8 math students. On to lesson 5. This is calculating the surface area of a triangular prism. So the first thing we need to do is just review the area of a single triangle all by itself. So that's really easy. You learned this last year. The area of a triangle is the base multiplied by its height divided by 2. So in this case, the base is 5 centimeters multiplied by 3 centimeters, which is the height. Divide that by 2 for a surface area of 7.5 centimeters squared. So we need to simply take that and apply it, everything you've learned from rectangular prisms and now triangles, and put that into a triangular prism. So we'll do this in 3 steps. You're going to determine how many sides are congruent or the same within a triangular prism. This will reduce the amount of work that you have to do. Then, if there's any sides missing, you may need to use Pythagorean theorem to find those missing sides. And finally, you're going to add all of your sides up together and calculate the total surface area of that triangular prism. Here's some examples. So let's figure out which sides are the same, and that will make our life a lot easier. So in this triangular prism, these 3 little marks here mean those 3 sides are the same. So that's an equilateral triangle, which means we've only got 2 calculations to do, because the 3 rectangles are the same and the 2 triangles are the same. Let me show you what that means. To calculate the surface area of our rectangles, it's the same thing you did for rectangular prisms. Length times width. And for the triangles, you're going to multiply base times height divided by 2. So you can see for our rectangles, the area is 9 times 3, which is 27. And the triangles, the area is 3 times 2.6 divided by 2, which is 3.9. Now, when we calculate the total surface area of this 3D prism, we need to take the area of the rectangle and multiply it by 3, because there were 3 sides that were the same. And for the triangles, there were 2 of them, 1 on each end. So we need to take that 3.9 meters and multiply it by 2. You wind up with 81 meters squared plus 7.8 meters squared, and the answer is 88.8 meters squared. All right, let's do another example here, except this time we're missing a side length. So you can see on my original triangle, I don't have side C here. You won't see many questions like this, but you may need to calculate some. So here we go. I'm going to take just half of the triangle, and I'm going to redraw it down here. And we're going to use that to find the side length C. So I'm going to start with C squared is equal to A squared plus B squared. Well, A squared is 16, B squared is 9. That means C squared is 16 plus 9, that's 25. In order to find the side length C, I take the square root of 25, and I wind up with the side length being C. Let's look at another example here, or the same example I should say, and now we're going to apply what we've learned about that side C. And I've just got the answer here, 5, written in both my 3D shape as well as my net. So here we go. My triangles, I've got base times height divided by 2. That's 6 centimeters times 4 centimeters divided by 2, which is 12 centimeters squared. The green sides of this, I've got length times width, which is 9 centimeters times 5 centimeters, and 45 centimeters squared is the answer. And the yellow bottom, area is also length times width. That's 9 centimeters times 6 centimeters for 54 centimeters squared. Now I need to find the total surface area. I'm going to take the information from above and add all that together. So for the 2 triangles, it's 2 times 12. For the 2 sides, it's 2 times 45. For the one bottom, it's just 54. There's only one of those. I don't need to multiply it by anything. If I add those answers up, it's 24 centimeters squared plus 90 centimeters squared plus 54 centimeters squared. The total surface area of this shape is 168 centimeters squared. All right. This example, we will not need to use Pythagorean theorem, but it's a different shape. So you need to remember that you've got two triangles in this shape. You've got a bottom that's different from the back, that's different from the front. So in this case, we're going to have 4 calculations to do. We've got our triangles, and then we've got the back, the bottom, and the front. In order to calculate the triangles, again, base times height divided by 2, that's 11 times 12 divided by 2, which is 66 centimeters squared. But again, because there's 2 of them, I'm going to multiply that answer by 2. So my triangles is 132 centimeters squared. For the back, 12 centimeters times 5.5 centimeters for 66 centimeters squared. For the bottom, it's 11 centimeters times 5.5 centimeters for 60.5 centimeters squared. And for the front, it's 16.3 centimeters times 5.5 centimeters for 89.7 centimeters squared. That means when we add up all of the rectangles plus the triangles, we get 348.2 centimeters squared. All right, so that was a very, very quick lesson. What you need to do is go back and just pause this video at each one of those steps and just kind of follow along. Make sure you check what's color coded. All the colors belong together for the different nets here. And just kind of work those questions out yourselves and see where the numbers come from. Once you're done that, head to the class notebook. There are some practice questions on finding the area of triangles. There are some practice questions on calculating the surface area of triangular prisms. And if you get both of those done, there's some extra practice on page 180, numbers 5, 6, 8, and 10. Good luck. You'll do awesome. Don't be afraid to chat with Ms. Muirhead and I tomorrow, and we can help guide you through the assignment. Thanks very much.